Hello, this is Muneer Ahmed. Today we will discuss about chill water flow rate, related formula and calculating chill water flow rate in different applications such as chiller and district cooling. Now let's look into the formula of the chill water flow rate, calculating chill water flow rate. See, the formula to calculate the chill water flow rate is GPM is equal to tons into 24 divided by delta T in degrees Fahrenheit. Please note this, delta T shall be in degrees Fahrenheit. GPM is units of volumetric flow rate of chill water. So GPM is gallons per minute, whereas delta T is chilled water return temperature minus chilled water supply temperature in degrees Fahrenheit. Now let us go to after formula. Now let us calculate the chill water flow rate in different applications. As we are aware, for chiller as a standard we are having 2.7 degrees centigrade, which is 55 degrees Fahrenheit, and 7.2 degrees, which is 45 degrees Fahrenheit. This is chill water return temperature and this is chill water supply temperature. Here the delta T is 10 degrees F, whereas in district cooling we are having 14.4 degrees centigrade, which is 57.9, and 5.5 degrees centigrade as supply temperature, which is 41.9 Fahrenheit. So here delta T is 16 degree Fahrenheit. When we insert these delta T's in the formula, GPM is equal to 1 ton into 24 divided by 10 is equal to 2.4 GPM, whereas in district cooling application 1 ton into 24 divided by 16 is equal to 1.5. So here in chiller application 1 ton is equal to 2.4 GPM, whereas in district cooling 1 ton is equal to 1.5 GPM. So 1000 tons is equal to 2400 GPM, whereas in district cooling application 1000 tons is equal to 1500 GPM. Now let us look into the effects of chill water flow rate in chiller plant and district cooling plant. See, as we have seen earlier, for 1000 ton for chiller application it will be 2400 GPM, whereas in district cooling plant it is 1500 GPM. See, now let us analyze how this 2400 GPM and 1500 GPM will affect on different parameters of chill water system. For 2400 GPM the pipe dia will be dia 10 inch, whereas for 1500 GPM dia 8 inch will be enough. So while we select the pump for 2500 GPM we need higher capacity, whereas for 1500 GPM we will be selecting lesser capacity pump. Power also here it will be higher capacity, whereas in district cooling plant it will be lesser capacity for same tonnage. Installation cost will be more, and similarly here district cooling installation cost will be less. Operation and maintenance cost also will be more, as this will be consuming more power with respect to district cooling plant. I would like to highlight here a point while you are finding the delta T. Before finding delta T, first you need to convert the temperatures from degrees centigrade to Fahrenheit of both return temperature, supply temperature, and then you need to find the delta T.